anyway, though, yeah. So yep. So these are 4 operations. And so now let's do an example of like combining these in a really complicated way, and then we're gonna work with that, and it's gonna be hard. And then we're gonna see why set identities make things easier. But we have, but we have to see why it's hard first, because mathematicians are human beings. We don't do anything unless we don't do anything unless it would be. We don't do anything in math unless it makes something else easier, if that makes sense. Otherwise, why do it? And so I'm going to show you why we care about set identities. So let's say U is residence of Bikini Bottom. So this is a SpongeBob metaphor. U is the residence of Bikini Bottom. We live in Bikini Bottom. We're going to have A equal residence of SpongeBob's, which will be SB, SpongeBob's street. We'll have B equal Krusty Krab, or KK, Krusty Krab employees. And then we'll have D equal to aquatic animals. So this is our setup. We have residence Bikini Bottom, which is a universe. So A, B, and C, A, B, and D are going to be elements of our universe, are going to be subsets of our universe. And then A is residence SpongeBob Street, B is Krusty Krab employees, and D is aquatic animals that live in Bikini Bottom. And now let's consider who is in AC union BC, or A complement union B complement minus D complement complement. That is the $1 million question, or however much a class of Virginia Tech costs these days. Who is in this set right here? And Herman, I'll give you, first of all, I have no idea if you recognize SpongeBob metaphors, but I'll give you a couple seconds if you want to think about this and try to guess who's going to be in this set. Tim.
I don't really know. I'm just guessing here. Is it just the squirrel? Is that who it is?
It's definitely the squirrel. Good job pointing that out. Yeah. Because D's aquatic animals, and then we're gonna kind of subtract D complement from this. And so D complement, the only resident Bikini Bottom that's not aquatic animal, Sandy Cheeks, the squirrel. And so from this set, we're gonna subtract the squirrel. So this like this whole thing's not gonna include the squirrel, but then we do the complement. And so the complement of something that doesn't contain the squirrel will have to contain the squirrel. If that makes any sense. But yeah, there's also gonna be a couple other people. So I guess not people, that's the whole point. So let's, oh, you know what? I guess Mermaid Man and Barnacle Boy. Forgot about them. We're just gonna say it's Sandy Cheeks. Anyway, the point is, none of this is the point. Just the point is the form of this. So let's go ahead and kind of like write out what all this is and see how we figure this out manually. So A complement, so it's the complement of residence of SpongeBob Street. And the complement just means everything in U that's not in A. And so this is all Bikini Bottom residents that don't live on SpongeBob Street. So A complement is going to be all Bikini Bottom residents not on SpongeBob Street. We're going to union that with BC, B complement, and B is Krusty Krab employees, so B complement is just all Bikini Bottom residents that aren't Krusty Krab employees. So this is all BB residents, not Krusty Krab employees. And then we're subtracting D complement from this. And this is the part where you notice the squirrel thing. Great job. And that is D is aquatic animals. And so if we take the complement of that for Bikini Bottom residents, well, that's just all Bikini Bottom residents that are aquatic animals. All B residents not aquatic, we'll say. So that's what we have right there. And all BB residents not aquatic. This is just Sandy Cheeks. Sandy Cheeks the squirrel is the only non-aquatic resident of Bikini Bottom. I guess you could maybe make an argument for Merman and Barnacle Boy, but I don't actually know their background. Like, is Aquaman an aquatic animal? Like, is a mermaid an aquatic animal? I would argue it is. Anyway, the point is, let's just say Sandy Cheeks for now. If you want to include Merman and Barnacle Boy, follow the same proof, put them there. Anyway, so we have this right here. And now if you look at it, all BB residents not on SpongeBob Street, union all BB residents not Krusty Krab employees. Let's think about what this is for a second. I mean, putting this together, this would be, just by the definition, this would be all X, so all residents of Bikini Bottom, such that X not on SpongeBob Street, and X not work at the Krusty Krab. Because that's just what it is. Oh, sorry, no. Or. Because union's or. So X is a resident of Bikini Bottom, so that X is not on SpongeBob Street, or X does not work at the Krusty Krab. That's really what we have here. But if you're not on SpongeBob Street, well, this includes everybody that doesn't work on SpongeBob Street. And it includes everybody that does not work at the Krusty Krab, because as long as they fit one of these things, they're in the set. That means that this set really just includes everybody. Oh, this is the set of people not on SpongeBob Street. Actually, let's just leave it like that. This is fine. And so that's what this union is. They're going to subtract Sandy Cheeks. So this is everybody in Bikini Bottom that's non-SpongeBob Street or has worked at the Krusty Krab. And then we're going to subtract Sandy Cheeks from this. So subtracting Sandy Cheeks, this is just all X in Bikini Bottom such that X is not on SB or X is not on or does not work at the Krusty Krab. So if X not on SpongeBob Street or X not work at the Krusty Krab, and now we're subtracting Sandy Cheeks from this set. And so Sandy Cheeks will be in this set. Because Sandy Cheeks she's not on Sandy Street or not on SpongeBob Street, and she doesn't work at the Krusty Krab. So she's not going to be in this set. So you also have to kind of shave off Sandy Cheeks from this set. This is going to be all X in Bikini Bottom, so the X is not on SpongeBob Street, or X not work at Krusty Krab, and X not Sandy Cheeks. And now we're taking the complement of this set at the very end. So the complement of this set is just the opposite. It's the opposite of everyone that's not on SpongeBob Street or not with the Krusty Krab and not Sandy Cheeks. And so the opposite of all this, if we kind of go through our logical identities, right? This is all X in Bikini Bottom such that X is on SpongeBob Street and X does work at the Krusty Krab, or X is sandy cheeks. Because I think you can see why this is the opposite of this. Because this is everyone that doesn't work at the street or does not work at the Krusty Krab and is not sandy cheeks. So in order to be the opposite of that, you have to either be sandy cheeks or you have to work at Krusty Krab and be on SpongeBob Street. It's kind of complicated, which is exactly why set identities are going to be awesome. But anyway, I hope this makes sense. But then if we look at this, this is going to be, well, if you're on SpongeBob Street and you don't work at the Krusty Krab, or and you work at the Krusty Krab, well, people on SpongeBob Street, that's Squidward and SpongeBob. And the people that, the people on SpongeBob Street are Squidward, SpongeBob, and Patrick. And the people that work at the Krusty Krab are Mr. Krabs, SpongeBob, and Squidward. So, the only ones that both live on SpongeBob Street and work at the Krusty Krab are SpongeBob and Squidward. And then, or it could be sandy cheeks. So the point is, this felt complicated, but you could do it. You could go through all of these things right here and figure out exactly what it means, like write out what it means, right? And then do all the complements yourself and kind of do it manually like this. Yeah. I mean, you can do it. But this seemed complicated, right?
Yeah, it wasn't something that you could get like within a second, or but like it's not crazy though. It's not impossible for sure.
Yeah, good. That's exactly what I wanted to hear. So you could do this, but let's go over how we can do it even easier, and that's using set identities. So I don't have a clock in this room. So the time is 3 o'clock. Good. So let's go over a bunch of set identities.